Hi, how are we doing today? Boogie Woogie, the universe wizard here again today. And we're going to be Astrono my day, and I'll Astrono your day too. And we're going to be learning a little bit about our solar system today. We've already done a little bit of the nighttime sky and what we can see up in it. We talked about stars and what makes up their entire life and death. And now we might as well talk about the other things you can see up in the nighttime sky, which includes planets. And so we might as well go through the whole entire solar system. And so the first thing I'm going to do is go through basically the general makeup, the layout of our solar system, talk about who's all involved, who's all there, and then we'll throw in a few more numbers to give you an idea of like distance and such like that. So at the very center, but in this case, I'm only going to show like half of the whole ring, if you will. So I'm going to put the center, our sun, our star, over here on the edge. And that will be our baseline. Now, of course, during this entire thing, nothing I'm drawing is going to be to any kind of scaling. It's just to give you a general idea of the layout, because you wouldn't see anything really if I did it to scale, because everything is so spaced out. Well, you're going to see just how far later on. Spaced out, get it? But I might as well title this. What am I doing messing around? Solar System. Am I getting any better at drawing flat? Kinda. Okay, so we start off with our sun. It is our star. It is a white/green G2 star. All that we went through in the life and death of stars video, if you've seen that. But just to give you a general idea for those of you who haven't, it's a slightly below average size star that's been keeping us alive for a while, and we're very happy for it to be there. It is yellow appearing on Earth. It is white when you're out in space. But if our eyes weren't a little bit weird and took an average of all the colors, it would actually appear green, which I think is just really cool. The first planet we would have after that is a little dude, Mercury. And when we get through all these, we're going to also talk about what constitutes a planet. And I'm going to reiterate why I think Mercury should be out and Pluto should be in. That's basically what I'm trying to get at. So we got Mercury, our first planet. After that, we're going to have Venus. I want to keep it all the same color so that when I add in all my extra bits, I can color code it there. Mercury, Venus, big ol' Earth. We know her. We'll just put a big E. Earth, you are here. In case you didn't know, this is where you live. This planet here, third rock from the sun. Then we have Mars. And then we have this big old chunk of crap. It's not really crap, but a bunch of rocks, bunch of debris, the asteroid belt. Now, one thing to keep in mind, the asteroid belt is nowhere near as compact as this, or as any shows that you've seen where they're out in space and like, we gotta go through the asteroid belt. Oh! It's never that bad. There's all kinds of space through them. You can very easily go through the asteroid belt and not see a single asteroid. Asteroid belt. Now, up until the asteroid belt, these four right here are our inner rocky planets, is what the general term can be. So we got inner Rockies, or terrestrial type planets. Inner Rockies goes for those four. Come out here, and our first guy is going to be mumbo jumbo, but I'm not going to draw him too big, so it'll take up all my space, is Jupiter. After that, we have Venus, and I'll put the little ears on them. I said Venus, I meant Saturn. Got Venus on my mind. Venus, Uranus, Neptune, Pluto. I'm putting Pluto on there. We're going to talk about why. I know he's not officially, but I'm going to talk about him. And then we have another big old band called the Kuiper Belt. It's very similar to the asteroid belt that we just previously talked about, but a lot of these asteroids are much more ice intensive. Instead of just being solid rock and dust, we have more ices involved here. And then you could also go further out for things such as like the Oort cloud and other dwarf planets like Haumea, but we'll just stop at the Kuiper Belt for now. So from the asteroid belt until the Kuiper Belt, and Pluto counts in this Kuiper Belt region, he's kind of dancing around in there. These 4 planets here are going to be our outer gaseous, or jovial, sometimes you'll hear jovial, outer gaseous giants. That T went well. Glad we did that. So our 4 outer giant gas planets here, they all actually, funny enough, have some amount of rings. Saturn's are the most easily seen. Uranus would probably be in second place and stands out quite well in that he looks like he's just kind of on his side. But both Neptune and Jupiter even have ring systems, though they're just very, very thin and made up of very small particulates, so it can be really hard to see them. Now, there's more in between these gaps, of course. There's not just the planets, we also have moons. Mercury doesn't have anybody with him. He's all by himself, it's just Mercury. Same thing with Venus. Venus don't got nobody. Earth, however, does have the one moon called the Moon. So we got the nice easy name to try and remember there. Mars has 2 moons. One will be called Phobos, and the other Deimos. Fear and panic, which goes well with the god of war. More on that in a minute. Jupiter has dumb amounts of moons, if we want to be honest. 60, 70 plus. Just all dancing around. Obviously, they're all in different orbits, but for the sake of keeping the drawing simple, we're just going to put them right there. 60, 70 plus. Different widths and orbits outside. Saturn, 30, 40 plus moons. Uranus, in the teens, 20s. Neptune, in the 10, 12, 15 area. Pluto, I believe, has about 4 hanging out with him. 3 or 4. Funny enough, even Pluto has some friends, despite everyone saying he's not a planet. Now, talking about the orbits, as far as like the distances of each of these planets, I had to bust out my little space encyclopedia so I don't mess up any of these numbers because they're very particular. So, we're gonna give you the 2 sets of numbers here. So no orbit of any of the planets is actually circular, in which it's a perfect circle in the sense that the sun is at the very center and that planet just goes around nice and evenly with the radius being consistent the whole time. That's not true. All of our planets actually happen to orbit in what's called an ellipse, which if a circle has, for example, one point in the middle, and you could take out your radius and draw it in a perfect straight line, perfect circle, all the way around, that'd be a circle. One point, and the length of the radius stays the same. An ellipse, or what you might also call an oval, same kind of thing, has 2 points, 2 centers, if you will. And how it works there is that any one spot, the length to the 2 centers stays consistent. So even if I move my dot over here, I'm very close to this first center, but very far to the other one, which will balance out later on when I'm down here, and it's almost split in half. At any point, the distance between you and the 2 foci, the 2 center points, it'll be the same. The sum of those distances will be the same. So all of our planets lie on these ellipses, so when I put 2 different numbers, It's just to show you the closest that any of these planets gets to the sun and the furthest out any of our planets get to the sun. Okay, so for Mercury, well, actually, I'm going to switch it. We're going to make it to where blue is closer because it's going to be blue shifted towards the sun, and red for red shifting, getting further away. So when it's closest, it's going to be in red. I will put it in miles and in kilometers. That's what the two different numbers on top will be. So all the top will be closest, all the bottom will be furthest. So for Mercury, we have 28.5 or 45.9 million miles or million kilometers. 28.5 million miles away from the sun at its closest, or if you prefer, 45.9 million kilometers from the sun. And at its furthest, it will be 43.3 or 69.7 in mega miles or million miles or mega kilometers. Million kilometers. Pretty far. For Venus, I'm going to get rid of our labels here just to make it a little bit simpler. But you got 66. We're going to round a little bit to keep the numbers simpler. 66 or 107. And then at its closest, or furthest, I mean. Oh, it doesn't really move that much. It's interesting. 67, not 66, 67 and 110. So we see a huge difference between Mercury's distances, not quite doubling, but in the realm of double its distance from the sun to between its two distances from the sun during its orbit, is what I mean to say. So for the case of Mercury, the changes on temperatures during the year will definitely change. But for Earth, we're going to see that the numbers won't change really all that much to where that's not why we have our seasons. Earth is 92 or 147, which also the distance between the sun and the Earth also gets summed down much more easily to 1 AU, 1 astronomical unit, which is just the 93 million miles between the Earth and the sun. On its furthest out, Earth's 94 and 152. So yes, 2 million miles might seem like a lot, but not when you compare it to the 92 million miles. So yes, between 92 and 94, 2 million miles seems like a lot, but it's not compared to the numbers themselves. The percentage is fairly small. So that's why we don't see a whole big influence on our seasons based off of where in the orbit Earth is. Because funny enough, for the northern hemisphere, when we have our winter, that is actually when the Earth is closest to the sun. Because it's more important about the tilt of our Earth, which part of the Earth is facing the sun, and getting more direct sunlight. Not that you're necessarily closer to the object giving off the sunlight, but more that you're getting more direct rays on any given spot. Let's see, we're halfway there almost. Mars is at 130, or 208. Getting all kinds of fun stuff on this board. 155 and 250. We have a pretty big gap between Mars and Jupiter because Jupiter at its closest is 460 million miles away, or if you prefer, 740 million kilometers. And at its furthest, just keep the cap off. 506 and 816. Saturn, 837, 1347. Get that big divide. There we go. 936 and 1506. Don't worry, I'm almost done. We're getting there. We'll even include Pluto's. Let's just go over the top real quick. So Uranus is 1700 or 2734. Neptune, these are at their closest, 2770 or 4456. And lastly, Pluto is at essentially 3,000 miles, 3,000 million miles, so he's 3 billion miles away from the sun. Or if you prefer, 4.7 billion miles, billion kilometers, excuse me, from the sun. All right, glad that's done. So, the planet that is the closest to the sun at its closest is 28.5 million miles away from the sun. And the furthest out planet at the farthest point in its orbit is sitting around 4.5 billion miles. Huge difference. So, if you think about it, let's use another color for the math for a half second. We got 4, 5, 0, 0, 0, 0, 0, 0, 0, 0. Divided by 28, 5, 0, 0. Let me make sure. 28.5 million. So there's thousands. There's that. It's just to show you how much further out Pluto is from Mercury. Get rid of all your zeros. 3, 4, 5. So then we have, geez, this is just going a bit nuts. Pull out your calculator if you want to make it quicker. That's what I'm going to do. Because now I realize it's not quick and easy all the way, in a sense. Not for my little brain. 285. The total being Pluto is 15.8 times further away. So you could put Mercury away from the sun, obviously at its closest, and do that 15 times before you'd even reach Pluto. Nuts. Freaking nuts. There's all kinds of crap in there. That gives you a general idea of the scaling of our solar system. But let's talk a little bit more about each planet in particular and what makes a planet and all that jazz. One moment, please. Hope you're all doing all right out there. Hope you're having a nice evening / time of day, depending on when you're seeing this. Okay, so let's just draw out our first dude. Mercury. Okay, some things to talk about with Mercury. Its diameter, so from one edge to the other edge, if it was just a nice circle like we have it here, is what we're gonna call a nice clean 3,000 miles. Just keep it simple. We're learning about the solar system while drinking? That would be nice. I wish. I can suck the medicine out of the eraser if I want, but I don't think that's gonna taste or feel good. So maybe after. The tilt that Mercury has is a big ol' zip. It don't tilt. So the axis here, 0 degrees. Basically, the weird thing about Mercury is that its day is longer than its year. Whatever numbers it really is, because this encyclopedia seems a little bit off now that I'm reading that. What I mean by its day is longer than its year is, let's say we still have our sun over here, and you start off on high noon right here. There you are. Hi, you. It will take longer for Mercury to rotate enough for you to go all the way around to high noon. You would have gone around the sun before that happens. Meaning, if let's say you started this journey on your birthday, you would have another birthday before it was high noon again. You would have your birthday at, let's say, 10 a.m. Mercury time. Even though it rotates so much slower, it's not the same as 2 hours in that sense. And you just got a whole lot taller because of your birthday. You're older now, so that's great. But you get the general idea. The day is longer than its year because it spins so slowly, which is just nuts. The amount of atmosphere that Mercury has is none. You can call it essentially zero. It doesn't have much to it, thanks to it being only about 30 million miles away from the sun, which sounds like a lot, but cosmically speaking, it's not. Mercury gets baked alive, and since he's small, doesn't have a lot of gravity, he already has a hard enough time holding on to any kind of gaseous material to create an atmosphere. It doesn't help that the sun helps evaporate it all off. So you couldn't breathe anything on the atmosphere, and even if you did, for the most part, it's got things like sodium, potassium, argon, things that some of them might have sounded good for your body, but not good for breathing. So Mercury is not the most hospitable place in the world. In case you were wondering, there's like no chance. You don't want to live on Mercury. It's not a fun time. Next up is we have, changing pages. There we go. We'll do a different color. Yeah. We got the queen herself, Venus. Aphrodite. It's not actually the queen of Greek mythology, but she's basically one of the few women out in the solar system, so we're going to give her the queen position. So the diameter here for Venus is about 7.5 thousand miles. So over twice as much as Mercury. Mercury's just this little tiny thing. He's only barely bigger than our moon. Tiny, little baby thing. The amount of tilt that Venus has is, weirdly enough, I'm gonna draw it like this, 177 degrees. Should have gone the other way, but nearly flipped all the way around. So instead of how a normal planet would have its north pole here and its south pole here, Venus is different in that those are actually switched. Its south pole is on top and its north pole is on bottom. And so it will spin, it will rotate in what is often called retrograde, meaning just backward motion. Because if you were to watch it compared to the other planets, let's say all the planets were rotating around this way. Let's do it like this. Rotating around this way, you would look at Venus and notice that it goes this way. Just how she is right now. She's interesting. A year for Venus lasts about 230 Earth days. The reason why I keep saying in that kind of way is because an Earth year takes 365 Earth days. Well, for Venus, it takes about 230 Earth days for it to go around the sun. And its day is 243 Earth days. So again, according to this encyclopedia, its day is longer than its year. So you would have 2 birthdays every day. In between 2 high noons, you would have 2 birthdays. A weird way to think about it, but pretty much what would happen. Venus is famous for being extremely hot. So on Mercury, the temperatures there range between about minus 270 up until 800 degrees Fahrenheit. Whereas Venus sits around a nice old, call it a clean 900 degrees Fahrenheit. Or if you want to see it in Kelvin, because some of you might, because I love it. 1173, damn it, Kelvin. There we go. Really hot. Your broiler on your oven sits at about 500 Fahrenheit. And it's almost twice as hot as that. And it's that hot all the time. The reason is Venus has an extremely thick atmosphere. So much so that any picture you see of it, including this one here, you're not seeing the surface of the planet at all. You are only seeing the clouds. Even at parts where you might be like, oh, it's a little bit darker right there. There's like a mountain peeking up. Nope, that is just a different colored cloud. It has such a thick atmosphere of mostly carbon dioxide, some nitrogen, some sulfur is thrown in there. It has a very powerful greenhouse effect. Same as we have here on Earth, where you hear about greenhouse gases and how they're such a big deal. A bunch of greenhouse effect is happening on Venus. You can imagine that we have, let's say, the atmosphere of Venus extending out to here, just for the sake of our drawing. And the sun sends in all kinds of visible light. It'll pierce through some clouds. It'll bounce off through some of them. That's what makes Venus so bright and shiny, in a sense, is that there's a lot of light bouncing off the clouds, never making it into the planet. But there's all kinds that will make it all the way down to its surface. Some will get bounced around inside the clouds, and some will make it onto the surface. And when that energy makes it all the way down to the ground, it will heat up whatever rocks and such are on the surface. And when that material tries to give off its heat, because anything that you heat up gets hot because it's trying to release that heat, all that heat is gonna do, which we'll do a different color so you realize it's a different wavelength of light. This is heat. It's gonna try and rise up, but once it gets to any of these clouds, it bounces right back down. It gets trapped in because these gases keep that light, that infrared heat light, from escaping. So you get this huge buildup of heat all the time because visible light is just always coming in from the sun. And what makes it down to the surface gets trapped in there. It heats up the rocks. The rocks try and give off the heat. They can't, so the heat comes back down. And then they get hot still, so they try to give off their heat, and they can't, so the heat comes back down. And so it gets to be 900 degrees Fahrenheit about the entire time. There is no cold side. You can't just like, oh, at least tonight it will cool down. Nope, because even though the sun may not be shining on the dark side of Venus, there is so much heat contained in the entire ball that it's spread out over the entirety of it, and it's just always 900-ish degrees Fahrenheit. So, if you're wondering if you could live on Venus, no, not likely. It took a good while before we had any spacecraft be able to survive landing on Venus. The first, I think, about 3 or 4 spacecraft that went towards Venus to try and land on it died on their way in. And the first one that actually survived the whole way without burning up and dying lasted about 20 minutes before he too just got overheated and bye-bye. So that's Venus. So Mercury, not gonna live at. Venus, not gonna live at. I'm not gonna talk about Earth because you live there. You know enough of Earth. It's fine. You want to do an Earth Science Day? Go to it somewhere else. This is space. I'm just kidding. The one thing I do like to talk about with Earth, just because not everybody's aware of it, is that Earth has a magnetic field, which I should do in a different color. Mercury and Venus do not have magnetic fields, and it isn't necessarily common for planets to have it. It's not like something super rare, but just because you're a planet doesn't mean you're gonna have a magnetic field. There you go. So there's Earth. The reason why I point out this magnetic field is because it's very important when it comes to trying to mitigate the influence of the sun. Because not only is our sun giving off light, giving off heat, it's giving off all kinds of charged particles. You can think that all kinds of pluses and minuses are being flown out from the sun, all out in all kinds of different directions. Luckily, thanks to our magnetic field, which we have because we have a good deal of iron, a metallic substance, in our core, and it's spinning, allowing for us to have our magnetic field. The field itself, as you know, a positive charge and a negative charge. So let's say this negative gets caught into the field. Well, it's just going to go on a nice ride all the way to the plus side and just spin around or get deflected off. Positive, same thing. Gets caught up more towards the negative side and can go dancing around or get deflected off. Now, there are two weak points in our magnetic field, at the very North Pole here and at the very South Pole here. And when that happens, the energy from the sun, these particles, can get thrown right into there, get thrown at our oxygen and nitrogen atoms and such, energize them, those atoms release light, and we get the aurora borealis, or the northern and southern lights. All those are just particles from the sun smacking on in on our air. They're getting energized, they give off light to try and get rid of that energy, and we get a nice pretty effect. So that's Earth. Can you live there? You sometimes feel like you can't. You can live there. Okay, the final inner planet we'll talk about, because that's all there is, will be Mars. There's Mars. There we go. Mars. Mars has a diameter of about 4.2 thousand, because I'd use decimal, 1,000 miles. Our Earth, you could call it about 8,000. So if you remember, Mercury was about 3,000, Venus is sitting at about 7.2, and Mars sits at 4.2, which is kind of weird for some people. I know the first time that I learned how small Mars was, it was kind of strange because I always remember thinking that Mars had kind of been like a bigger brother to Earth. But that's not true. Earth is the largest inner planet, and in close second is Venus. They're almost brother and sister. They're kind of twins in a way like that. And despite Mars being the one we're always paying attention to as far as, people could go live there, more complicated situation and story for another day, it's almost half the size. It's a fairly small planet, all things considered. Not all too much bigger than Mercury. Mars, though, in other ways, is fairly similar to our Earth. It has a tilt, of 25 degrees, where Earth has about 23. One day on Mars takes about 25 hours, where we have, essentially 24. And the year is obviously going to be different, where we have 365 days, and Mars, it takes about 680. There's been all kinds of speculation on whether we could live on Mars, but the fast answer is right now it's really hard, because there is no water on Mars to speak of, small amounts of ice at the poles, but it's still not really enough to be like, we'll just heat that up and drink it. It would be more complicated than that. And there isn't all too much of an atmosphere left on Mars. He's a little bit small, so he, again, like Mercury, has a tough time holding on to gaseous material, so he has a very thin atmosphere, and for the most part, it's mostly made up of carbon dioxide. So not too bad if you're a plant, but since most of you watching this are probably not, harder to breathe. So for now, Mars is kind of a work in progress. If we want to live there, we have to do some what's called terraforming, meaning earth forming, earth changing, doing all kinds of things to make it to where we need to heat up Mars because it's also pretty cold there. It has an average temperature of like -9 degrees Fahrenheit. And that's taking an average across the entire planet, which will give you some perspective if you think about the average temperature on Earth is 59 degrees Fahrenheit. So that's including Antarctica and the Death Valley. Averaged out 59 degrees. So to have your average be -9, that's cold. So we have to make the atmosphere thicker so that it can heat up, and that we can also make it to where things can actually breathe, like plants, so that they can give off the oxygen we need so that we can breathe, and then the whole cycle can go. It'll take a long time for that to happen, but could happen. I'm going to skip the asteroid belt because it does not have planets in it. It does have a couple of dwarf planets like Ceres, but I'll save that for Pluto on what's exactly a dwarf planet. All right, big boy, Jupiter. Now with Jupiter, I might as well mention the naming for all of the planets. They are all Roman gods, which if you know anything about Roman mythology, it's essentially Greek mythology, but with different names. So Mercury being Hermes, Venus being Aphrodite, Earth being Gaia, Mars being Ares, Jupiter being Zeus, Saturn being Kronos, Uranus being Uranus, same thing, Neptune being Poseidon, and Pluto being Hades. So the king of the planets here has a diameter of about 88,000 miles. So over 10 times Earth. Big boy. It's a pretty big boy. He has a tilt of 3 degrees. So if you want to count that as anything, sure. It takes him about 4,000 days to go around the sun for him to have a year, but it has a fairly quick day. His days only last about 10 hours. So in between seeing high noon and high noon, it's only about 10 Earth hours before that happens. So it's whipping around, especially if you think about how big it is. Woo! It's spinning. The average temperatures here, about a minus 186 degrees Fahrenheit. So that's pretty cold. And the majority of Jupiter is made up of hydrogen. There's some helium, a little bit of methane and such like that. But such a huge amount of hydrogen and helium makes anyone who's paid attention to the stars, which watch the Life and Death of Stars video to find out more. But Jupiter kind of seems almost like a star, because our sun, for example, is made up mostly of hydrogen, and then there's some helium. Jupiter could have been a star if things had been a little bit different for him. It just doesn't have enough mass, doesn't have enough stuff to where there's enough gravity to squish that material down, to force the hydrogen together to make helium, and so that he can give off heat and light. So to us, he's a large planet. In the grand scheme, he could have been a stillborn star, if they prefer to think of it that way. A brown dwarf star is what they often are called. They're just below that line before they can actually create any heat and energy. But they're still big, they're still gaseous, and all kinds of hydrogen and helium within. Could you live here? No. There's not a ground that you can really talk about, and even if you could get to a hard enough surface like the icy-ish core, you'd be crushed by all of that atmosphere that it has. Because if you think about it, he's 10 times more diameter than the Earth, and the majority of that is just air. More stuff, more clouds. So imagine having all those extra cloud bits on top of you. That's a lot of air pressure. You would not be happy. In fact, you'd not be alive. So I guess you don't have to worry about being happy. Okay, next up is Saturn. We'll do Saturn in blue, it don't matter. Saturn, and we'll draw a nice big old ring on there. Saturn's diameter runs in the area of 75,000 miles. Still a pretty big boy. Still about 10 times as wide as Earth. Not quite as much, but in that area. It has a tilt of about 26 degrees. 26 degrees. And when I get to Uranus, I'll explain why I've been showing the tilt on all these planets, because you might be like, well, that's kind of a weird thing to talk about. Like, why do I care? When we get to Uranus, I'll explain. So for Saturn to go around the sun, it's going to take about 10,000 Earth days, which, to put it in a more easy way, 30 Earth years. So the Earth will go around the sun 30 times before Saturn does it once. But just like with Jupiter, it has an abstract or juxtaposed short day, in which it takes only about 10.5 hours for it to do a full day. So it's still also spinning around like a crazy man. Average temperature, minus 290 Fahrenheit. Still cold. Very cold. Not living there. And just like with Jupiter, it's mostly hydrogen with a little bit less helium, a little bit more hydrogen here on Saturn than it was compared to Jupiter. And you may have heard that, you could float Saturn if you had a big enough pool of water. It's the only planet in our solar system that has less density than water, so it would actually float, weirdly enough. Despite how big it is, it's more important about mass and density than it is about size when it comes to buoyancy and float. So it'd be weird, but you could have Saturn as your bathtub rubber ducky if you had a big enough tub. Which, just have to be 75,000 miles long at least to fit the thing. That's big. And that's Saturn for you. Again, you're not living there. Sorry. Both with Jupiter and Saturn, you have a chance of living on its moons. Saturn a little bit tougher because it's much colder out there. But you could, in theory, live on Io, Europa, Ganymede, Callisto, over by Jupiter. Those are some of the larger moons that Jupiter has. And since they are pretty good spots, with all things considered, Io is just covered in volcanoes, so not great. But you probably could have a decent chance on something like Europa. And when I say probably, I mean like still damn small chance, but all things considered as far as trying to find life or someplace where you yourself could live. Under the surface of Europa, you could. It's a moon there that has a nice icy surface, but is believed to have a bunch of oceans underneath, like a large water ocean. So you could live under there. Seems weird, like you think you'd freeze, but it'll actually get warmer as you go towards the core of a planet. Like if you think about the core of ours, it gets molten and hot. So the more further down those oceans you'd get, the warmer it'd be, and the higher chances that you could live. But let's not say that your chances are good by any means. Okay. Next, Uranus, planet number 7. And no, it's not your body part, it's Uranus, and you will refer to it as such. It has a tilt of 97 degrees. It takes about 30,000 Earth days for it to go around the sun once, which turns out to be, I believe, about 80 years. So a whole person could live out their whole life before Uranus will even go around the sun once. But a day lasts about 17 hours. So the outer planets, despite them spinning around so long, it has not much of an effect of how fast they're spinning. There's more complication on how it makes sense that the further out you are, the faster you're still spinning, where Mercury and Venus are almost getting close to not being able to spin at all. But another conversation for another day. Now, we're on Uranus. I said I'd talk about the tilt thing. So the reason that we have any seasons, the reason for the season, is because of any planet's tilt. The more tilt that you have, the more extreme of seasons you will experience. So at the least amount of seasons, you would have 0 degrees. As you can imagine, energy from our sun, the light, with however far out you are, depending on whatever planet, you can essentially think that the energy that gets to you comes at a straight line. So you got some energy there, some energy there, some energy there, and some energy there. If the planet has no tilt at all, each portion of that planet, each latitude, fatitude line, is going to experience the same amount of energy throughout the entirety of its orbit. If you're near the equator, you're always going to be getting a large amount of direct sunlight, allowing you to be very warm here and have that be all the time. The poles are going to get the light, but at a more indirect angle, so they won't get as hot. Because if you take a flashlight, which luckily enough, I just happen to have one here. I got a damn bright one, but hey, it sells the point. you have direct light and you have this nice clean circle here. You're getting the most amount of energy out of it. If you indirect it though, it's the same source, but now all that light and energy is spread out over a larger surface. So any one given point is getting less energy and thus not getting as hot. Same thing happening with planets and with us with our seasons. So the North Pole and South Pole in this example are getting a lot of indirect light, so they're not getting a lot of energy, and they're going to stay cold because they're never going to be pointed towards the sun in this example, so they stay cold, just like how the equator will stay hot. For Uranus though, it has the most extreme seasons because, think of it, if you live on the North Pole, at one part of the year, you're going to be facing right towards the sun. Now, a planet's axis will stay in one direction all the time. So you can imagine that if we have my eraser here, now I got this darker portion here and this lighter portion here, and we have the sun right here. It doesn't matter what part of the year it is, the axis will be pointing in the same direction the entire time. So the dark portion will always be facing out towards me, no matter what time of the year it is. Woo. So, one part of the year, the North Pole of Uranus is going to be pointed right at the sun. Oh, jeez. I gotta turn down that sound sometimes. Like all zoned in that pwing. Thank you for the follow. Happy to have you. Despite the jump, it was still fun. Anyway, North Pole, pointed towards the sun, getting all kinds of direct sunlight, getting very hot, just like it'd be at the equator for that planet that had no tilt, or at our own, let's say. At a different part of the year, at a different part of Uranus's orbit, that North Pole is going to be pointed away from the sun, getting no sunlight at all, and becoming frigid. So it's going to go from being the hottest spot on the entire planet to being the coldest spot on the entire planet. And all of these portions are going through very similar extremes because, you know, the planet is still spinning. So some portions sitting on this side here, this part of the year, are getting all nice and warm because they're facing towards the sun. But then when it gets to be a different part of the year, let's say half of the orbit later, it'll be nice and cold. Oh no, Uranus does rotate. The part that to keep in mind is that its pole faces in the same direction. So this is, let's say, if we're going off the reference of the North Pole here for Uranus, this would be the North Pole's summer. Ignore the sun, I'm gonna block it. Halfway through its orbit, which takes about 40 Earth years to do, the sun will be on that side. Because, you know, Uranus will have orbited around, but for the sake of drawing the picture easier, the South Pole will be facing the sun. And so things will flip. Instead of having the North Pole getting all the sunlight and getting nice and hot, the South Pole will, getting nice and hot. North Pole gets cold. Here, South Pole gets cold. So Uranus has the most extreme seasons, and that's how we get any of our seasons on any planet, is because of the tilt. If you don't have a tilt, you don't have seasons. We have some relatively mild seasons because we have a tilt of about 23 degrees, which isn't too bad. It's a nice little bit. So we get to have some seasons without having total extremes. Like, yeah, it might seem bad that Alaska will have, 20-something hours of daylight and then go down to 4 or 5, none. But imagine if much more of the planet experienced that. If it was more common of a thing to where, pretty much everybody gets to have a full, 24 hours of day in the summer and 24 hours of night in the winter. Think about it that way. If we had the most extreme seasons, our summers would involve only daytime, only daylight, and our winters would involve only nighttime. Not fun. Could you live on Uranus? No. Too far away, too cold, sitting at minus 360 degrees Fahrenheit, more or less. What's it matter if it's a little bit more? It's still frigid. And there's not much of a surface you could talk about, despite if you got down to its icy core, you could stand on it. But again, you'd be crushed by the atmosphere. Oh, you're not having a wonderful time. 2 more planets to talk about. Planets, yes, I know. I like talking about Pluto. I love that debate. And we're going to get into it a little bit. We'll have time for it. Last commonly accepted planet is Neptune. The big dark blue one. Neptune has a diameter of about 30,000 miles. So you can compare that to Earth, sitting at about 8. So not too much bigger, 4 times as wide. It's not too bad, but much bigger area, of course, different math. Neptune has a tilt of about 28 degrees. Has an average temperature of about minus 320 degrees Fahrenheit, so pretty cold. It takes 170 in that area, Earth years to go around the sun a single time. You will never see Neptune go around the sun once. Every human being that's ever lived, even the ones that have the Guinness World Record book for the longest life, will not live long enough to have Neptune go around the sun a singular time. Nuts. Its days, though, about 16 hours. So, although you couldn't live through a whole year of Neptune, the days are quick. So if you're having a bad day, it'll go by real fast. The atmosphere on Neptune is just like Jupiter, Saturn, even Uranus. Mostly hydrogen, some helium, but a lot of the blue caused on both Uranus and Neptune is thanks to methane that they have. Not even all that much either. Like Neptune being as dark blue as it is, has only about 1% methane. So even that gives it enough to be nice blue. Okay, now we gotta talk about the man with the plan. The one who's so influential and we love him so much. Pluto. Why do I love Pluto so much? Because he's been at the center of catastrophe and conspiracy and what do we even accept to be reality, and well, whether you think it's that dramatic or not. So Pluto. We're more going to talk about what makes a planet, what doesn't make a planet for this guy. So there are 3 rules that the astronomical associations that we have delineated in order for us to look at any object that's out in space and be like, is that a planet? Can I count that as a planet? Rule number 1. So we'll just call this rules. Number 1. Must be large enough. This is in no particular order. Large enough that it turns into a sphere. The reason for that is because we find that any body, any planetary or space body, that gets to be large enough, it is going to force itself down into a sphere. Because you can imagine, the point of gravity for any object, even our human bodies, our gravity comes from our core, the very center of it all. You're gonna get some gravity to happen here, which gets balanced out by the gravity coming from this side. Some here, some here, some here, some here. Now the reason why they get into this spherical shape is because at any point before it got to be a sphere, if it had some, holes in it, let's say, or even some mountains, these portions here would have more gravity pulling on them, and it would decrease on the way up, but it would still pull this material down to fill this gap. This right here, you got some gravity here that's pulling onto this gravity, that's pulling onto this gravity, pulling onto this gravity, so there's just more mass sitting here, causing it to get pulled in, and eventually, despite Pluto being all weird looking like that, ooh, let me look. Paper arguing for another redefinition of planets. Yes! I would love that. Very interesting, and it would include Pluto and a lot of moons and planets. Interesting. I'd like to read that. I will propose again what I think planets could be defined as. Not very official in any way in a sense, but you'll see whether or not you like it. Mine's very simple. So anyway, first rule, Must be a sphere. Rule number 2, which I think is a little bit lame as well here. It must orbit a star. That's just to get rid of any wandering planets that you might see out and just floating out in space without a star, which I think is interesting because the word planet comes from the word wanderer. So to get rid of the term wanderer for anyone that's wandering, kind of weird to me, but that's just how it is. Much more useful definition. Oh, if you do find that, send that to me. I want to read that. That'd be cool. In any case, rule number 2, orbit a star. Rule number 3, that's the one that knocks out all kinds of bodies like Pluto. Must have what is called a clean neighborhood. Now this is where it also gets to be very situational and why it's not the best system, in some people's opinion, including my own. Good. See, Pluto, you got a dirty neighborhood. That's why you're not a planet. So what does that mean? Dirty, clean neighborhood. It means that anything to be considered a planet should be A, large enough that it has enough mass that it can turn itself into a sphere thanks to all the gravity, but also be able to take any material, whatever it is, that's hanging out near the planet. It needs to have enough gravity to either take it and bring it in onto its surface or to have it whip out in some weird other orbit. Oh, you're my favorite. Thank you, super obnoxious. So for any of you that like to see this paper, join the Discord. There's a link below. If on the off chance it's expired, let me know. I'll re-up it. In any case, so a planet must be large enough and have enough gravity that it will either get rid of by absorbing, essentially, the material or throwing it off into some other direction. Now, the reason why it can be very situational and why it's not the best is because, yes, Pluto does not have a clean neighborhood. He resides out in the Kuiper Belt, which, if you remember near the beginning when I drew out the whole thing, was like that icy, cold asteroid belt near the edge. Not really the edge of the solar system, but the edge of the drawing. So he has all kinds of other little icy asteroids relatively close to it. Now, of course, this doesn't include moons. You can obviously still have moons and be a planet. Those are more larger chunks. We're trying to clean out little pieces of dust and rocks and stuff like that. The problem, though, is although Pluto might have a dirty neighborhood because of where it is and how it's too small, and, none of the inner planets have any crap around them, all the inner planets, Mercury, Venus, Earth, Mars, if they were in the same location as Pluto, none of them would be planets, including Earth. Earth is still not large enough to have enough gravitational influence to fully clean out its neighborhood, either through, smacking it down or throwing it out. The reason why it is because Earth is close enough to the sun, to which that big ball of gravity and solar wind is either gonna blow off anything that's relatively close or suck it and burn it on in, keeping our neighborhoods clean. So that's kind of like the weird situational thing that we have in our solar system, to where none of our inner planets would be a planet if they were where Pluto is. And that's why I would switch out Mercury for Pluto, because here's what my simple planet definition would be. It only involves one word, and some of you might like it, some of you might not. And those of you that have talked to me before about space know that I say this crap all the time. Science! Hi, Verithorn. You came in just an important time to hear about what makes a planet, in Boogie's opinion. The universe wizard, what does he think? What should be counted as a planet? And it involves one word. Let's make sure you're nice and dry. Activity. That's all I need for it to be a planet, in my opinion. Semi-scientific opinion. Because something like Mercury is innate and not doing anything where it's at besides being closest planet to the sun. It doesn't have any kind of tectonic plates that are moving around causing any kind of earthquakes. It doesn't have any kind of volcanoes. It doesn't have any kind of weather. It is literally just sitting there, no different than any asteroid would. It just happens to be a sphere around the sun and has a clean neighborhood, again, thanks to the sun. Pluto, on the other hand, being way out as far as he is, he's so cold, he's able to hold on to some amount of atmosphere, enough to where you could kind of count that there is one. Mercury, you can't. So there is weather. There's icy geysers, small amounts, that happen on Pluto or like on Enceladus, another moon that's currently considered a moon. Those things, I don't care if it's a moon currently now or if it's orbiting another planet. It can still be a planet if it has activity. It's doing something. It's being active. If we think about with stars, we consider them dead when, let's say, our own sun becomes a white dwarf, because it's not doing what it's initially supposed to. It's not doing an active thing. It's not actively taking hydrogen and turning it into helium. It's still giving off heat, but that's just leftover, basically, from what had happened earlier in its life. So if we can consider a star to be alive when it has activity, then a planet is considered alive when it has activity. It would then become a dwarf planet when it loses that activity. Or if you want to keep, I'm fine with keeping the spherical thing, but a lot of these things are going to get kind of summed up in there anyway, because you're going to have enough mass to turn yourself into a sphere in order to hold on to an atmosphere anyway, or have enough activity to where you have some kind of volcanoes or tectonic plates happening, some earthquakes, even though it'd be Mars quakes, Neptune quakes, depending on where you are. So I would sum down how any body can be considered a planet on one thing alone, and if it has activity. Does it have any kind of activity? Meaning, is it doing anything? Is the atmosphere doing something? Is the crust of the thing doing something? Yes, planet. No, dwarf planet or asteroid or something else. That's where I'd cut it off. So yes, Pluto is a planet to me. Mercury's not. Mercury pisses me off all the time because he's dead and boring. He's gray. There's nothing happening. He's just hot and next to the sun. That's it. Do we have any questions on anything in the solar system that we may have before I sign out for today? I got my encyclopedia here on space stuff to do any numbers if you're worried about sizes and particulars at any point. Glad I got to do my rant about Pluto. You got to do that every once in a while or keep that pent up, and it's not good for you. For any of you that want to read a little bit more about planets and what could be defined as a planet, what may end up changing things, or might, if we're lucky, be just an influence, join the Discord below. Super Obnoxious has supplied to us a very nice sounding article talking about how there could be ways to redefine what is defined as planet. And I'm going to be very curious to see what this person has to say. I hope it's something like activity, and based on what Super says, could be pretty close. Okay, so if there's no questions, I'll say my goodbyes. Goodbyes. I'll miss you. I love you. More or less. So today, we got to learn about our solar system in a very general sense as far as the layout, what star we had, what planets we had. There was an asteroid belt, a Kuiper belt. We also talked about each of the planets as far as general size, tilt, seasons, any kind of activity they may or may not have had. And then we got to talk about here at the end what could be considered a planet, what is currently considered a planet, and the possibilities of what may ever be considered a planet. So thank you very much for coming to see this stream. I very much hope you enjoyed it. And hopefully I'll see you sometime next week when we do our streams again. The next time I see you is the next time I do. Have a good time until then. Bye for now. Universe Wizard out.